Everyone, welcome back to my channel. So I have already done a video in obtaining Avogadro number, which is a question which appeared in 2022 UPSC Physics optional paper. So there was a small mistake in this question. For in that question, I have taken the wavelength of the X-ray as 0.1512 nanometers. So there is an order 10th order mistake in that question. So now I am doing a detailed calculations here in this video so that anyone can check it at home and reply me if there is any mistake. So let's go to the question. The question is the wavelength of a prominent X-ray line from a copper target is 0.1512 meter. The radiation when diffracted with 111 plane of a crystal with FCC structure corresponded to a Bragg angle 20.2. If the density of the crystal is 2698 kilogram per meter cube and atomic weight is 26.98 kilogram per kilomole, calculate Avogadro number. So the question is not very easy. You need to already, as I already told, this question is we need to correlate many things from chemistry and solid state physics. So first thing we are given with is that the wavelength of the radiation lambda equal to 0.1512 meter. So let's write what is given here. We know that the Bragg equation is equal to n lambda equal to 2d sine theta. This equation is a very famous equation and anyone know this equation. From this we can find out d as equal to n lambda by 2 sine theta. So this is equal to let's take first order refraction. So 1 into 0.1512 divided by 2 times sine of 20.2 degree. So you get the answer as equal to 0.2189 meters. So remember, I have taken lambda as 0.1512 meter and the difference, the interplanar spacing, I am getting as 0.2189 meters. So from the interplanar spacing, once you get, we know that if this is correspond to a diffraction from HKL plane, we will get d is equal to a by root of h square plus k square plus l square. So from this we can calculate a as equal to d into root of h square plus k square plus l square. So here HKL is 111 plane. So value of d we have already obtained. So we can obtain this as 0.2189 into root of 3. This value we will obtain as 0.3791 meters. So anyone who is watching the video, please check whether the values are right. If I have made any mistake, or you can also point out that. So now it is given that the structure is an FCC lattice. So for an FCC lattice, the number of atoms in the unit cell will be 4. This can be easily proved, but there is no need to prove it here. So the number of atoms is 4. Now we know that we are given with atomic weight Ma as equal to 26.98 kilogram per kilomole, and density rho is equal to 2698 kilogram per meter cube. Okay, given these two things, we know that number of atoms is always equal to Avogadro number into number of moles. Number of moles is equal to given weight divided by atomic weight. Now we can calculate these two things. So given weight we can calculate as we have volume into density. Mass, we know that mass divided by volume is equal to density. So, mass is volume into density divided by atomic weight Ma. So, in the previous equation, we have number of atoms 4. So, 4 is equal to Avogadro number into this value given weight by atomic weight. So, this value is B into rho divided by M into Ma. Sorry. So, from this Avogadro number Na is equal to 4 into Ma divided by V into rho. So, here Ma is the atomic weight and V is the volume of the unit cell, rho is the density of the crystal. So, density of the crystal is given in the question, atomic weight is also given in the question. Now, we have to obtain the volume. We know that volume of the cell, unit cell is equal to A cube. So, we already know the value of A. Value of A is 0.3791. So, we substitute all the values here. We can substitute here. So, 4 into 26.98 divided by 0.3791 whole cube into 2698. Substituting all the values, what we obtain as 0.73417 per kilomole. This is what we obtain as the Avogadro number. So I think this question, from where we started and where we are ended, like please reread the question again and then find out the connections that it make with what we have learned earlier. So that is how we can solve this. I think there is no error now. I have solved it correctly. If there is any mistake, please comment in the comment section so that I can rectify this. So with a new question, we will meet in the next video. Till then, goodbye.